Okay, so one thing we didn't finish yesterday, or today actually, is the very last part of our notes, which says a special type of exponential decay involves the half-life of substances. And usually we talk about this, we talk about radioactive half-life. Okay, so the nice thing about this one is half-life literally means it's losing 50% or half of its life, or half of its value really, each time. So that means the multiplier is always exactly the same number. It's always going to be 0.5. Because 1 minus 0.5 gives me 0.5. And if you lose half every time we calculate it, then it's losing 50%. 100% minus 50% leaves me with 0.5 or 50%. So I don't have any idea how to pronounce this. Ismuth, I guess, 212 has a half-life of approximately 60 seconds. Find the amount of Ismuth 212 left from a 25-gram sample after 300 seconds. So the original amount, that's the same idea as principal, is 25 grams. Okay, so that's what we substitute in for P right here. Half-life, this is my same multiplier always, is 0.5. Then 300 seconds, I have to figure out how many of the time period that is a half-life of that substance have passed. In other words, in 300 seconds, 5 60-second periods have passed. So T is 5. And then we calculate that and get 0.78125. The amount after 300 seconds is 0.78125 grams. So down here, write an exponential decay function to model each situation. Then find the value after the given amount of time. A 30-gram sample, that's my initial amount, or P. And again, I always have the same multiplier for half-life, so that's kind of nice. So 30 of iodine 131. That's the part of the name. So the 131 does not mean these numbers have value that I have to plug into anything. So don't just, sometimes when you're used to, in a math problem, looking at a word problem and saying, all these numbers have meaning in my problem, and all these numbers I have to translate into something in the problem. Not true here, because that's just the name of the substance. Okay? Has a half-life of about 8 days, and we're checking about 24 days. So my time is going to be however many of the standard time period, the half-life time period, have passed. 24 divided by 8 says 3 of them have passed. So my T is 3. So I'm going to do 0.5 to the third. That gives me 0.125 multiplied times 30, and I get 3.75. So after 24 days, 3.75 grams are left. The last one here, 40-gram sample, that's my initial amount. Again, this 24 is just part of the name. It has a half-life of 15 hours, and 60 hours have passed. So the number of time piece, or the number of half-lives is what we call them, that have passed is 60 divided by 15, which is 4. 4 half-lives have passed. So that's going to be to the 4th power. So 0.5 to the 4th power gives me 0.0625. I'm going to multiply that times 40, and I get 2.5. So there are 2.5 grams remaining after 60 hours. And that's all you got to do on this.